Bismillahirrahmanirrahim. Assalamu alaikum and welcome to my channel. So today we would be discussing about the detailed uh, performance and working of a line following report. The specification of this line following report would be that it would not be only following the line, it would also be avoiding obstacles and detecting them with the voltage and current sensors. And this would not be a dummy robot that is available all over the market, that we make a simple time following robot that just goes from straight to the path from where which it is moving, and it does not come back, and it does not know the way from where it has moved on. So this would also be having an SD card, and also be having we would be explaining the from function and performance of the SD card as well. So there are two types of functions that code that we would be discussing over here. The first one would be the code of Arduino ID, and the second one would be C++. C in Atwell Studio. So first, I would be explaining you the structure of it. The structure as given over here. This would be the structure of our Arduino and our whole program. We are using our Arduino Mega because we would be needing a lot of pins. So that's why we are using Arduino Mega. The 2x6 because it gives us flexibility of a lot of pins, and it has the capacity of many ports. And as you can see, we have used a lot of things. Even just a simple LCD uh, contains more than two ports, and that's why we have used Arduino Mega 256. This is our sensors array. Basically it would be attached of IR sensors that would be attached over here, but just to make it the circuit more easier to detect and understand it properly, I made a sensor array over here, as you can see over here. Then there is our obstacle detector ultrasonic sensors. It has 4 pins at 5 volts, 5 volts at 5 volts, then trigger, then echo, and then ground. Then this is our SD card. SD card we would be using just for the path that would be going backwards. Like if it has reached its position, it should be knowing from where it has gone through. And this is our SD card pins: SCS, MOSE, MISO, and SCK. SCK was for the clock, MISO was the DO, and MOSE would be from DN. Then CS would be for CS, and this is schematic model of it, but in original life of we have more pins of SD card as compared to over here. Then this is a voltage sensor. In this diagram, we would be analyzing a voltage sensor that we have made with our own selves, because in Proteus, the Atmos Studio, the current voltage sensor is not available. So it is very difficult for us to find it in Proteus the software. So we have simply made the voltage sensor over here. But in our uh, as the function, but in our projects, we have used a voltage sensor module. It has 3 pins, just like this current sensor. It has 2 pins of positive and negative of the battery. Then it has 3 pins. One is the output, one is the positive, and one is the negative. And it would be placed in the parallel. When I would be explaining about the state diagram or the VC or the block diagram, I would be explaining it as in well. Then after this, we have our driver, that is LM23 L298. L298. It has in this part, in this simulation, in this I would be explaining you two types of simulation: one with enable and one without enable. And I would be explaining what is the main difference and why we had made it like this. First of all, this is with the enable, and as you can see, all of them are attached to the PWI pins. The ultrasonic sensor pins are also attached to the PWI pins, and so are the voltage divider. Then this is our LCD. This is our LCD, and it has connected. You can also connect these pins with the pins the configuration, but these are attached to the potentiometer, and they would be attached just like this in the PCB module as well. And these are RS, RW, and E. RS pins is for our enabling pin, setting pin. This enable pin is for the enable, and RW is for the right pin. Then we have it diode. We would be only using the last four one. We wouldn't be using all of the seven ones. The reason for this is that the R value when we were implementing this on our Arduino, so we only needed to display that voltage. We only needed these four values, and these were just wastage. They were going in the wastage. So we start to make a circuit more simple, simplex. We didn't use them in the PCB as well. So this was our all of the explanations of all the parts. Now let's go to the block diagram. And after block diagram, we would be explaining the further thing. Okay, so I would be explaining you the block diagram now. So before moving to the block diagram, if you just wanted to make an simple line follower robot, you can use a simple that is simplex one Arduino Uno or the Arduino Nano as well. So as you can see, we have used Arduino. From this block diagram, there are few things that could be explained that were not being able to explain in the schematic one. First, the current sensor is placed in the series, and the voltage sensor is in the parallel one. As you can see over here, it is in series and it is in parallel. Then we are using two types of IR sensors. One is the IR sensor module. It has 5 IR sensors, and one is the simplex one, that is that is the normal IR sensor that we have in the that we use in the daily life. So there was a difference between both of them, and that this one IR sensor module detected white black line, and although on the contrary to this IR sensor that we use the normal light, this detect white line. So the while programming and while making the flowchart, we have made this as a difference and corrected it because according to it they both differ from each other, and the last IR sensor in the voltage and current module, the configuration this it would be changed, and so would be the truth table as well. Then the we have encoders over here that were not in the simulation, but they were added afterwards. So in the encoders one, there are two encoders that have three pins each. One was one was positive and the next ground, and then with the Arduino ID. So in encoders, basically this happens that this as many turns as is created, it creates impulses, and with these impulses, it would calculate that how many pulses are created. So it would detect the path and store it in the SD card. So these were the inputs. The inputs are voltage sensor, current sensor, ultrasonic sensor, IR sensor, and encoders. These are the inputs of it. Now, what would be the output? The output will be LCD, SD card, and the motor driver. So, a motor driver, all pins of motor driver are PWI pins of IR ultrasonic sensors are also PWI, and the rest are the digital pins. Let's move on. Now we would be discussing about the flowchart and state diagram. Okay, this is simplex one SD card state diagram. This has four functions: stop function, left function, forward function, and right function. Now, on the stop function, it would move from forward to stop. It would only stop when all of them are zero. Then this means both motors are zero, and this forward would only stop would only move to forward when all of them are positive. So after that, the left would be then all the three are any three or the last, except the last one, all of them are one, it would convert to left. Then for the right one, if all of them are one, except for the leftmost, then it would be for towards the right. Then the reverse is same for 1 1 1. It goes for the forward one. Then after that, it would go back to itself as well when one one all of them are one one, and it the same goes with the left right one and same with the forward and stop as well. There is cases where the don't care situations where it also stops. This is a truth table. It is a detailed truth table because there were six sensor used, so six sensor outputs were given. The dash here represents the don't care situations, but there would be a lot of don't care situations because of the number of items. Then this is a flowchart. Now, what will happen is first it will start and calculate the voltage sensor and each current module of each of them. Then it would check for any obstacle. If yes, then it would calculate the distance and avoid the distance and move further and then go to start. Now, if there is no obstacle, then what would happen that it would check that if it moves right, left, forward, or stop. So for this, it would first check the function of forward. It would check the function of forward, and when if it is declared no, then it would go to the check the function of right. Then after the left, and so after left, it would go to the check for the right, and then after right, it would check for stop, and that's put in the circuit. So there is also something that this is the visual description of it. Like if you can see these are the sensor modules placed ahead, and as soon the system was going straight, and now it is turning left. So why is it turning left? Because you can see over here, so it detects the line like this. And then the turning right as well, and then the forward one would be the straight one, and then stop would be all of them are zero. So this diagram was uh, on IR sensors that detect white line instead of black. So that's why it would give was given this answer. Okay, this is our then code. Then I would be explaining you. Okay, so this was a code, a detailed code. The first of all, we have added a header file of our LCD. Now, why we have added an LCD file? Because we would be using it to display the values on the LCD. And basically, LCD has this LCD file is already built in the Arduino ID, and that would be same would be for the new big edge. Then for the voltage sensor. Now let's start for it. Voltage sensor, we simply do it that we detect for the voltage sensor. We first define, yes, that would be our ADF ACD pin, that would be A0, that on which this pin would be attached. Then after then we have declared few variables that are V out, V requirement, a resistor 1, resistor 2, that are shown on our voltage sensor module. And the RS1 and RS2 are the value are already determined from the data sheet, that are 30,000 and 7,500. then int value is equals to 0. Why we have created this 0? Because as soon as the circuit moves, if there would be any previous value of the where we val then stored in this in this code, then it would not start it from 0. It would convert it to that number and it would start from there. This could result in a faulty apparatus, faulty answer. That's why we have converted into is equals to it to 0. Then we would be checking for the checking of the encoder values. What we would be doing is that we convert int is equals int check in encoders is equals to 0. This would be a variable declare that we have done. Then also the steps is equals to 0. And again, the same reason for converting it for making it 0 before the starting of the program is the same, that if any value that was installed in it or saved in it should not affect the program's capability and efficiency. We have also done this for first one part was for the input for the first encoder, and second part would be for the second encoders, the two extra parts. Then we would for the current sensor we declare it A1 and say because VS is equals to A0. The sensitivity of the then the current sensor we have written as S66, and ADC value is 0 because it starts from 0, and the offset value is 25,000, 2500. ADC value voltage again, when ADC value is 0, the voltage is 0, current voltage is 0, value is 0, and then PT long is 0. And the delay time we have assigned over here is 300. Is a very nominal delay time, and it is a better way to implement to detect each and every state. Okay, now let's move on. Now, after this, we have also declared our sensors that are L1, L2, L3, R3, R2, R1. Then we have declared our DC, LC for the LCD, we have declared its pin configuration. The R is on 33, E is 35, and R4 is 37, R5 is equals to 39, D6 is equals to 41, and D7 is equals to 43. That are our values, and we would also be declaring it like this for and this is subject to be implemented absolutely correctly. Then after that we have five for the IS sensor. Now we have IS sensors. We would be declaring. Now we have named it like middle right, right side most, then closer to right side, closer to left side, and then left side, and mostly left. Now, after this, we have declared, then we would be calling our either input motors, drive motors, enable pins. So this would be for the motor driver, and then we would be declaring for the ultrasonic sensor. For the ultrasonic sensor, we had already added a file of new pic as I described in the start, that we have added two built-in files, and one was begin, and the second one was the light crystal. So for the ultrasonic sensor, we have already in the Arduino ID, we declare the maximum distance is equal to 200, but the C++, we declare do it in from the another method. So let's proceed on. In Arduino ID, there are two steps the most important. One is the step up and one is the loop. Now, after the step, this whole description and definition of this code. But what we had done, we had made a setup code, and we have put in the setup code here. We done it once. So what we do, we make it decide the pin modes, that if who is output, who is input, and as I have described in the uh, block diagram, we can easily differentiate between who's are the input and who are the output. Then from the LCTV, where we declare it measure for 25 volts. That would be start of it. Then after that we make two four functions that are the one first function is turn right. Now one what we would be doing in turn right, we would be declaring it enable a would be 60 and the input one would be high and the input two is low. Means the voltage from where it is going it is low and from voltage where it's coming it is high. And then left motor has both low because it is off right now. Only right motor is moving. Then on the other hand, then the avoid turn left would be opposite to the turn right, and it this all the first two enable pins are 0, and the third one is higher. Then it is a straight move. In this straight, both moves so straight. So the first input of the both of them would be higher, and the second would be lower. Then it is a backward function of over here that move right, move what we move the right motor, then left motor. We make it. How do we function it? Then they have the stop function. The stop function both are low. Now this is the function for made for the voltage. Now this function need to be understood by the EDC code conversion methods. Now EDC conversion method, what happened that we have already made it analog read. Analog read means it is EDC and it is analog read. It's an analog one. So after we declare V out for the V out calculation, we simply go for value multiplied by 5 divided by 1023. This is our a standard formula, and therefore the requirement we would be dividing the V out that we have declared or we have calculated early, divided by resistance 2 divided by resistor 1 plus the resistor 2. This is the voltage divider. After this, we would be declaring the value of V by this as it would be stored. As- Then we would do the current sensor. For the current sensor, we simply was implement the current sensor, and then we would be doing again the ADC. For this one, we would be ADC value, we write the analog read, and for the ADC voltage is ADC value divided by 1024 multiplied by 5000, depending on the pin scale. Current value would be the at ADC voltage minus offset voltage. So this is a huge deal. It could require risk. So let's see. And the further ahead of this would be the LCD clear function. LCD, when you set any function, LCD, it is must that you clear it as well. For this, we have LCD clear function, and this we would be having LCD cursor that would be 00. And then we would be having all the function for to implement the value of current. Then we have encoder. Encoder, we have two encoders, encoder left and encoder right. For this, we would be for the left encoder. First, we go to the circuit, we check the EC value, the digital value that would be coming from the pulses. And what we do that if the check encoder is equals to 1 now, then we would be defining that while check is equal to 1, we would be simply declaring it. If it is lower or higher, it would be proceeding that direction. Then we would be, if it is 1, then it would be adding as per requirement. It would with the function is moving till the function is moving. Then for the right, we would be doing the same one, but with the encoded two variables. Then we would be having ultrasonic function, and for this we have we have command of sonar dot png underscore scene. You must be knowing and reading the data table for understanding it perfectly and implementing it correctly. Then after this ultrasonic sensor, we would be declaring loop, and for the loop we are unsigned loop SD means we would be declared, and if CD is greater than 0 is greater equals to time delay. Then for this we would having all calling all the functions of voltage, current, or current or any other in this final moments, and we would be declaring it again. So for the rest sensor, we would be declaring we would be doing it. Now, in this, as you can see, there is a difference between there. It is a start time, net or night. How would we can do it? Like we have 0, 0, 0, 0, 0, 1. So this means it is moving from the left direction. Then in the next one, it is 1, 0, 0, 1, 1, 0, 1, 1. This is this would be done again and again according to the truth table, and it would be explained like that. So let's now see that our uh, we have done with the code. Now we would be doing the pure Proteus simulation. Now Proteus simulation, I would be showing you two. First one that is moving ahead. It is right now we have pressed the inner button that would be implementing a forward function. Now if I go to here, it is stopped because it would be opposite to each other and it would not be possible. It's a don't care situation. Then if we just simply press this, now if you're seeing it says L votes, this means it's left. Then we close it, it is again S. Then when I open this one, it is right. So it is just with the following the combinations we can see it as well. Now let me show you the project picture video. The video, but the project was made 4 to 5 times, and this was the final outcome of it. So, I hope you enjoyed it. Thank you very much, and Jazakallah.